Welcome to part 1 of the Chapter 7 review. In this chapter, we're going to be dealing with quadrilaterals. And so let's begin with problem 1. It says, find the sum of the measures of the interior angles of a regular 30-gon. Then find the measure of each interior angle and each exterior angle. So there are several questions that are being asked here. The first one is, what is a regular polygon? Regular polygons are polygons whose angles are all congruent and whose sides are all congruent. A 30-gon is a polygon with 30 sides, and we're looking for the sum of the measures of the interior angles of a convex polygon, and that has a specific formula. So let's go ahead and write that formula. And that's the sum, that's the Greek letter sigma, which stands for sum, is 180 times n minus 2, where n is the number of sides. So to solve this problem, we just need to put 30 in for n. So we have 180 times 30 minus 2 is 180 times 28. And these are all equals, which equals 50, 40 degrees. Okay, now the next part of the problem, we're looking for each interior and each exterior angle. Now, we don't want to have to draw a 30-gon, so that's all I'm going to draw is the bottom portion of the polygon. And we can see that these two angles are a linear pair, so they're supplementary. Now, there's going to be 30 of these exterior angles. And since all the exterior angles of a regular polygon or any convex polygon add up to 360, we can divide 360 by 30. And that will give us the measure of each exterior angle. And since this is a regular polygon, then we know that each one of these exterior angles is going to be equal. So that gives us 12 degrees. So you know each exterior angle is 12 degrees. And since linear pairs are supplementary, this angle is the supplement of this. So we know that this angle is 168 degrees. And so there's our answer to our question. Each exterior angle is 12 degrees. Each interior angle is 168 degrees. Now let's move on to problem 2. In problem 2, we have a similar problem. In this instance, we are given a hexagon, 1, 2, 3, 4, 5, 6 sides. So that's a hexagon. So we need to find the sum of the measures of the interior angles because we're going to use those to compute this x value. So for problem 2, we have the sum equals 180 times 6 minus 2, which gives us 180 times 4, which is 720. Okay, so the sum of the measures is 720 degrees. So that means this plus this plus this plus this plus this plus this is all going to equal 720 degrees. So 720 equals 90, that's this piece, plus 150 plus 130 plus 97 plus 120 plus x. So all these added up together gives us 587 plus x, and of course that's equal to 720. Subtract the 587 is 133. And that's our x value. So now let's move on to problem 3. In problem 3 we have a very similar situation, but this polygon is 1, 2, 3, 4, 5, 6, 7. This polygon is a heptagon. So to compute this, the sum equals 180 times 7 minus 2, which is 180 times 5, which is 900. So now we'll go ahead and add all these up, and those are going to equal 900 degrees. So 900 equals, let's start here with the x. So x plus 160 plus 2x plus 125 plus 110 plus 112, a little tedious, plus 147. So 900 equals x plus 2x is 3x plus this plus this plus this plus this plus this all adds up to 654. Now I'm going to subtract 654 from 900, which is 246, which is 3x, and then we're going to divide by 3. So 82 equals x. Hopefully not particularly difficult, just a little bit time consuming. Okay, now on to problem 4. In problem 4, they're giving us values for the exterior angles here now. So we know that the sum of the measures of the exterior angles of any convex polygon is 360 degrees. So we don't have to do the same calculations we had to do there. So for number 4, we know that 360 equals the sum of all these measures. So let's start with this one. So we have 7x plus 83 plus 33 plus 6x plus 49. That's a 4. Very bad 4. Okay, let's add these together. We have 360 equals 13x plus 165. Let's go ahead and subtract 165 now, which is 195 equals 13x. Divide by 13, 15 equals x. And that's problem 4. Now on to problem 5. In problem 5, we're into the world of parallelograms, and it says find the value of each variable. So this variable and this variable for number 5. These are consecutive angles, and the consecutive angles in a parallelogram are supplementary. So for number 5, we can find A by saying that this plus this equals 180. So 101 plus A equals 180. So that makes A equal to 79 degrees. And the opposite angles in a parallelogram are congruent. So we know that B is 101 degrees. Okay, now on to problem 6. Okay, in this parallelogram we have this side and this side are opposite sides, so opposite sides are congruent just as opposite angles are. So this equals this. So in number 6 we have A minus 10 equals 18. Add 10, A equals 28. And then for this one, we know 103 equals B plus 16 because opposite angles are congruent. So that means 87 equals equals B. And now on to problem 7. For problem 7, we're going to use one of the other properties of parallelograms, and that is the diagonals bisect each other. So that means this piece is congruent to that, and this piece is congruent to that. For number 7, we have C plus 5 equals 11. That means that C equals 6. And for D, D plus 4 equals 14. So D equals 10. And now let's move on to problem 8. In problem 8, we're going along a different route. Now we're given coordinates of a parallelogram in the coordinate plane. So we're going to have to find out where the diagonals intersect. So let's bring up a coordinate grid, and I've gone ahead and plotted the points for our quadrilateral here. And to find the point of intersection of our diagonals, we'll use the basic property that the diagonals bisect each other. So that's all we really need to do is find the midpoint of one of these diagonals, and we'll have the point of intersection. So let's go ahead and find midpoint of QS. So we have midpoint, of course, is the average of the endpoints. So the x-coordinate is going to be -8 plus 4 over 2. And then the y-coordinate, 1 plus a -3, which is 1 minus 3 over 2. So -8 plus 4 is -4 over 2, and 1 minus 3 is -2 over 2, which gives us -4 over 2 is -2, and -1. So our point of intersection should be -2, -1, right there. And we could go ahead and compare. Let's find the midpoint of this, and it should be the exact same point. So if we want the midpoint of RT, it's 2 plus a -6, which is -6 over 2, and 1 plus a -3 over 2. 2 minus 4, minus 6 is -4 over 2, and -2 over 2. So yes, in fact, we have -2, -1 as our midpoint. And we confirm that this is the point of intersection of both of our lines. So we can go ahead and, just for kicks, go ahead and draw that in. And we'll have 1 there, and 1 there. And there's our point of intersection. Now on to problem 9.